On this page of the review, we are in direct variation. Which of these, so just the first 5 for this section, which of these would we like to see, do, go over, have questions about? Yes. You guys have questions in this section? If not, we're going to move on to the next section.
Number 1, is the bottom middle one correct?
No. So this one would not be direct because it has a y-intercept. Okay. It's going to be in the same format as y equals kx, but y equals mx plus b is the same format, but your b has to be 0.
So, the top right one would be.
Top right would be.
I know, sir.
What page is this?
They're not numbered. It's a page that you put this. Okay. Do we have other questions in number 1 or in that section? There are more correct ones and not correct ones.
Do you have an example of why you first I want to check?
And why is that one going to be direct? Because it's in this format. You just have to know that you can rewrite it.
Okay. Y equals x over 2, and the last one would be that's the first 5, so it's one top then.
No, it's what we're dividing by x.
Oh, that one makes 0, so that makes so much sense because 0 is equal.
Any others in this section? So 2 through 5. So for this, you're given 2 numbers. Find the part of this where it says varies directly, varies proportionally, something. It'll have something afterwards. Whatever comes first is y. Whatever comes second is x. So the interest here, y, and the number here, x. To find the rest of this, we have to find k. It gave us this equation y equals kx, so we are going to use that to find our k. We also need to know that k equals y over x. If you didn't remember that, you could use this equation and solve for k, get rid of x by dividing both sides by x. So for this one, we're going to look for k first, divide y by x. So 6630 over 5100.
If it doesn't make so much,
And then we'll divide that so we get. yes, but both. So we now have K. Now I can look at the rest of the question. How much would she receive for the same amount of time if she had $2,000 in her account? So we're looking for, we have the amount deposited. We're looking for Y. So when we set up that equation, it would be Y equals 0.013 times the X. And we would multiply those and figure out what Y is. And because this is a word problem, we would need a label, dollars. The next objective starts on the same page. Questions on 6 before we flip to the next page. This one? Yes. For yes, yes.
That is the same.
Yes. So this is right because if you rearrange this, you multiply. So K equals YX is your other equation from this. So on the next page, look at numbers 7 through 11. I'm going to rewrite the formulas up here. Any of those questions you want to see to go over?
Do you have 14 and 18, please?
Just in the section right now. We'll deal with those later. That's right. If we don't have questions in the inverse section, the next objective is your joint and combined variation. Well, as you said, 14 and 18. Or like, is that what you said?
What?
14 and 18.
Yeah.
So 14 is just setting up the equation. S varies inversely as the square root of R. This is going to be S equals. You always need some K. In this case, inversely, you are dividing whatever by K, or from K, so over the square root of R. $18, we also have to set up first before we can start solving. So B varies inversely. B equals, you'll always have some K. Inversely, we are dividing as the cube of B. So B cubed, B to the third, not the cube root of. Then they give us numbers. They said B is 2, B is 5, so we can put those in. 2 equals K over 5 to the third. Use that to solve for K. So figure out what 5 to the third is. If you're not sure, you can use this. Here, hat, whatever you want to call it, above the division sign. To get K by itself, we would multiply 125 on both sides. but that's only part of the answer. So we found k, we still have to find the rest. Because now it's asking calculate b when b is 10. We're going to use that same equation, put 10 in for b, I'm going to put this on here for my next space. Put 250 in for k, and that's all being divided by b to the third. To get b by itself, we're going to multiply both sides by b cubed. Divide both sides by 10. And then the last part, to get b completely by itself, we have to get rid of the 3 by taking the cube root of 3. In your calculator, if you go into math, and then the fourth one, you can see that. It would be some decimal around 1 or 2 decimal places. Other questions on this objective or this page? Go on to the next page. Now we are in factoring by GCF. Which of these do we want to see you go over PowerPoint as well?
This one.
Goal for these is to find what they each have in common and divide that out of everything. So if you're not sure, you can list out the factors of each number. So I know the factors of 16 are 1, 16, 2, 8, 4, 4. And then for 48, if you were looking for all the factors, 1, 48, 2, 24, 3, and 12. Great, but not everyone does. So
Wow.
and then 24 is 1. And then I hear them. Yes, that's how. Find the number they each have in common. And Elijah, what was that? In this case, you'd have to divide by -4 since the first one is negative. You also have to find the variables that they each have in common. So look for the lowest exponent. That's the only thing that they could all take out or divide out. And divide that from each piece. So -16 divided by -4 would give us what? I thought this was easy.
You asked me. I mean, you told me to be quiet, so I'm being quiet.
1? the exponents. Negative 48 divided by negative 4 would be positive 12. Subtract the exponents. And then do the same thing for the last one. Have somebody comment sometimes. Here, there's nothing else to divide out of each of these. That's incorrect. It wasn't right. 8 was. These can all be divided by 4 works, so it's not the highest. So if you're dividing and you see that you can divide again, either you didn't divide by the highest number first, but still divide it. So you can either go back and fix it, or just divide again. Other questions on this page? Go on to the next. Now we're factoring by grouping. Which of these do we want to see to go over and have questions about? Look and see if they, Emma, yeah. 52. Okay. Look and see if they all have a GCF first. That may be the case, that may not be the case. For 146, I know we can divide 35 by 1, by 5, by 7, but 25 isn't divisible by 7. So not a GCF for everything. Split this down the middle and find the GCF of just the first 2.
Oh, 35 by 5.
Yes, 5 is the GCF. Part of it. They both have x's. Lowest exponent is 2, so x squared. And then divide out what's left. 7, subtract your exponents. This would be negative 5, and then there would not be any x's. Find the GCF of the last 2. It would be positive because this would be positive. Then your whatever's inside the parentheses should match. If it doesn't, something's wrong. Take whatever's outside the parentheses, put that together in parentheses. And then whatever's inside the parentheses, just bring down one of those. Questions on that before we do the next one? This one, we're going to look and see if they each have a GCF because some of these numbers are big. I know for 18, we can divide it by 2, by 3, by 6, by 9. I'm going to see if any of those work for all of them. Not 9. I think 6 works.
Yeah, 6 is good.
So that would be 15 x cubed minus 20 xb yu
4.
y then the rules are the same. Split it down the middle. Find the GCF of the first two. Keep bringing down the GCF on the outside. It is 5 and x. So that would give us 3u minus 4b. And then look for the GCF of the other side. Number-wise, they don't have anything in common except 1, so you would put -1. But variable-wise, they both have a y. So leaving us with 3u minus 4. So when you rewrite everything, you have the 6 on the outside numbers, 5x minus y, and the inside 3u minus 4. That looks for you, this is supposed to be a b. Right. When we come back, we'll go on to the next page. Alright, let's continue. Go on to the next page.
Oh, my bad.
Alright, from this page, factor in using difference of squares. Which of these do we want to see, go over, have questions about?
You could do that multiple, please.
156. Any others? So with difference of squares, you have to see, are these perfect squares? Is there something that says that would equal 16, that would equal 9, and the variables, and that you're subtracting. If those are all the case, you're going to have two sets of factors. And you're looking for what times what would give you 16?
4, 5,
What times what would give you x squared?
x.
And put that first. And what times what would give you 9?
That's 3, 5,
And what times what would give you y squared?
that's just 1.
And then put a plus in one and a minus in the other.
Okay, so it's a minus, then plus.
It doesn't
What does matter? Is that for the sign?
That's it for that question. Do we have any other questions on this page?
For example, like 160 would be so it would be 2a squared minus 5, and the other one, another 2a squared minus 1 plus 5.
Correct.
Gotcha.
Any others? We have questions about. Say that again. So you're thinking, what times what gives you a squared? And then what times what will give you 16 b squared? Other questions on this page? Okay, go on to the next one. So now we are factoring trinomials when a is 1. Find any you want to see, do go over.
Hey, can we go back to 166? I think very interesting.
So let's start with that one. We're looking for two numbers that multiply to be negative 30.
Oh, this one.
That also add or subtract to each side.
Do 10 and 3, but
Yes, one of
we'll
those
do
would have to
3.
be. where the variable is, you're going to put that first. And then the two numbers you found will go in those two values.
And I don't know if it's right.
Are there any others you want to see you go over? 67. So two numbers that multiply to be 14 that add to be 9.
Yeah, 7 and 2.
So if you don't know the factors off the top of your head, you can start listing out the factors, figure out which ones would add or subtract to 9. Any others from this page? Here? No, as long as it's not. And then here also same. Doesn't matter if you put it first or last. Other questions on this page? Go on to the next. Last section of factoring. Which of those do you want to see? Do you go over, have questions about?
Then can we do it on 178? That is very, very hard.
Okay. So first look, we didn't do this for the others, but we should have. Look to see if they had a GCF, they didn't. But this, look to see if you can divide something out of each of these.
It looks like it's looking like.
What were you going to say originally?
I was going to say 7.
That's too high.
That was way too high. So we can't do 2 because I'm not. So we can do.
What did you say? 7p squared plus 13p plus 6.
Oh, wait, 13 was in a big? Big on me.
Yes.
Does 3, 6, 9, 4? I'm just pretty sure.
Multiply 7 and 6.
Oh, look, my others.
And you're looking for two numbers that multiplies to be 42, but adds to be 13.
You try to remember 20. Um, 6 and 7?
Yes.
Oh, right.
So then you're going to rewrite this. 3, leave the first and last. Rewrite the middle as the two new numbers you found. Does not matter the order. Make sure you have the variable. And then now we have 4 terms, so grouping. Keep bringing down this GCF. Find the GCF of these two. Number-wise, it's just 1, but they both have a p. So that would leave us with 7p plus 6. Look for the GCF of the second two. They don't have anything in common in this case except 1. So 7p plus 6. So then we have the 3 from the outside. The p plus 1. And then 1 of the insides.
Now the question for one. Okay, so how do we connect?
Same way, except it doesn't have a GCF.
So how
Do you want us to do it?
Yes.
So look for GCF. If it doesn't have one, you skip that first step and move on to the second. multiply.
Okay.
You're looking for two numbers that multiply to be 9, but add to be negative 6. I'll finish it. Rewrite this into 4 terms. Split it down the middle. Look for the DCF of the first two. And divide that from both. Look for the DCF of the second two. In this case, 1 would work, but it would have to be negative. So then we have 3x minus 1 and 3x minus 1. Or 3x minus 1 squared.
So you always try to start off with, when it comes to this one, practice and stage, you just have to like figure over like subtract, multiply 50, like put them 182, do a multiply, to start off, you multiply 15 times.
Yeah.
Then you multiply that.
Other questions on this page? Go on to the next one. We are getting closer to the end. We are in now Unit 7. Solving quadratics by square roots. Which of these do we want to see, do, go over, have questions about?
You remember 186 and 183?
Our goal is to get the variable by itself. So solve it just like a normal problem. Add 5. Divide both sides by 7.
And then you just square root that answer.
Then you take the square root, but you have to remember that when you take the square root, yes, it'll be a positive answer, but the negative also works. So it wouldn't just be positive 10, it would be plus or minus 10, or the positive or and negative. And then write it as a solution set. So either plus or minus 10, or you can separate it, least to greatest. Questions on that one before we do the next one? $186, we would divide both sides by 100. And see if that fraction could be simplified. It can't, but I'm going to show you. And then you're going to take the square root of both sides. If both of these numbers are perfect squares, then you're going to take the square root of each one individually.
Like 3 and 10.
And then do plus or minus. You can write it as a solution set, or, I'm sorry, write it as a combined solution set, or separate them. Other questions on this video?
188.
So for 188, add 9 to both sides.
Oh, just. I never asked that question.
Take the square root. In this case only, there's no such thing as a positive negative 0. So we'll just 192 is already solved, almost already solved. So you just have to take the square root.
Which is 6.
Plus or minus. Right? Okay. Other questions on this page? Go on to the next one. have your calculator, you need that for this. And which of these do you want to see to go over some questions about? 194. Okay. In the calculator, you're going to go into y equals. If there's anything in there, clear it out. Type in your equation, 2x squared plus 4x. Go into your table, second graph. And you're looking for where your y values repeat. Here they only go up, so I'm going to scroll up. And I see my y values repeating here. I'm going to find the middle and plot that point. -1, -2. And then I'm going to plot at least 5 points. If I can plot more, that's fine. If not, only 5. So -2, 0, and 0, 0. And then -3, 6, and 1, 6. And then connect them, make a U shape through them, draw arrows at the top. This also says to state the solutions. So look at where does this cross the x-axis and write those as ordered pairs. Any other questions on this page? None, go to the next page. So next objective is identifying solutions. Which of these do you want to see do go over and have questions about? We are looking for where does this cross the x-axis, and we have to write those as ordered pairs. So for 202, there are 2 of them. This would be -3, 0, and 1, 0. 204, there's only one place it crosses the x-axis, and that would be at 5, 0. These, you can have 2 solutions, 1 or none. And if it doesn't cross it at all, you just put none.
That's it?
Yes. Any others from this page? Go on to the next. Okay, and then the last section in Unit 7, quadratic formula. Which of these do we want to see? Do go over and have questions about. Emma? 211. Okay. This doesn't have it on there, but the test, the final will have this on there. Your quadratic formula, x equals -b plus or minus the square root of b b squared minus 4ac all over 2. Write that somewhere on your paper.
Oh, that's so easy. It is clear. Oh. Oh.
Then for 211,
Yeah. One second.
we have to label our A, B, and C values. And then we're going to put everything into the format. We'll start off, x equals negative b, which is 12, plus or minus, square root of b squared. You can put 12 squared or you can put 144, either or, doesn't matter. Minus 4, that's always there, times a, 11, times c, negative 14, all over 2 times a, which is 11. Then once you have it set up, you just start to simplify. Negative 12 plus or minus square root of 144. I'm going to put this part in the calculator all at the same time. Negative 4 times 11 times negative 14. 616. And then we can add those two numbers together. Then you have to see, is that number underneath the radical of the square root a perfect square? So in the calculator, we would do second x squared, type in that number. If we get a whole number, then we can simplify more. If we get a decimal, we're just going to break it apart. So we're going to leave this like that and just separate it into two things. Solution set, negative 12 minus the square root of 760 over 22, and negative 12 plus the square root of 760 over 22. Questions on that one or other questions on this one? So some of these will have an actual perfect square that you'll simplify it to that number and then you'll break it apart and simplify more. Do you have any other questions before we go on to the next page? Now we're in Unit 8. So this should seem more recent. We did this not too long ago. Which of these do we have questions on? Let's go over C, D,
Two.
you have more, we'll do those. So we're looking for the domain and the range of this. Domain, we're looking left, right. Just putting this as a side note. So furthest point to the left, furthest point to the right. Because this has arrows, this is going to keep going left and keep going right. So there are no stopping points. So if it keeps going left and right, the domain is going to be all real numbers. I'm going to write it both ways. Either in interval notation, negative infinity to positive, or in set notation, the x, the root e, and the root r. Range is lowest to highest. So we're looking for the lowest point. There is one at 3. And then highest, because of the arrows, it keeps going outward and up. So in interval notation, that would start at -3 and keep going to infinity. But the -3 would be a bracket, square bracket, because it's included. In set builder notation, it would be everything greater than or equal to, I put -3, that should just be 3, positive 3. Questions on that one before we do 219? These, you're just switching. So for 219, we need to write this. It needs to look like one of these. So in interval notation, this gives us two numbers between 1 and 10. So the 1 is included, the 10 is not. So the 1 will have a bracket, the 10 will have a parenthesis. Are there any others from this page we want to see, do go over? 22. So I think when we made this, it didn't like the infinity symbol for whatever reason. So that's why it says the word instead. But here we're trying to rewrite them to look like these. So if it starts at -4 and it keeps going towards infinity, that would be everything above -4 or greater than. This is a bracket, so greater than or equal to. X or Y doesn't matter. Other questions on this page? Go on to the next. So in 8.2, we have translated words, so we have to use those to write equations. Which of those do we want to see? Do go over first of all, Emma? 7. Okay. Any others? We have to remember the different things, the different words, where they go, and all those things. Vertical things go outside. Horizontal things go inside. I'm going to write this at the top. Your functions are going to look like one of these two things. These are the general formats. Y equals A, in parentheses x minus h squared plus k, or y equals a absolute value x minus h plus k. A little bit, one of those. You may not need all of the pieces, but it depends on the function. So for 227, our parent function here is x squared, so we're going to be using that first one. It tells us it's vertically compressed by a scale of 1/3, so this is going to be outside. And this would be our A. Translated 2 units down. Down is vertical. So that's also going to be outside. This would be our K. Reflected across the y-axis. So if this is my y-axis and it's doing this, that's horizontal. So that's going to be inside. This is not our h. This would be the number that goes in front of x. So using all of that information, we can start to write it. Whether you use f of x or y equals, they're the same thing. So we know our a value is 1/3. Then our parentheses. We didn't have an h value, but we need this reflected in front of x. That's just a negative. Squared on the outside. And then down 2 units would be minus 2. Other questions for this page? So for 31, our parent function has changed. It's now absolute value, so it'll be the second equation. Compressed vertically, that's outside. It tells us what that number is, so that's A. Reflected across the x-axis, so if this is your x-axis, it's doing this. That is vertical. So this is going to go in front of A. On the outside. And then it's translated 12 units left. Left is horizontal. So that's going to be inside. And that's going to be your H. But we have to do the opposite. So let's start to put all of that together. F of x or y equals. We have an A, but we also have something that goes in front of the A. The reflected would make it a negative. Plus the absolute value signs. We have an H. You're thinking because it's moving to the left, it would be a negative. But because our formula has a negative already, if I put a negative in there, it would become a positive. So this would be H plus 12. And we wouldn't have a K in this case. Other questions on this? We're going to do one last page and then we'll stop for today. So on the next page, which of those did we want to see? Do you go over and have questions about? any others? Okay, so then we have one of each type. So you can either look at the transformations and use them that way. You can look at the table, compare them, all kinds of things. So we first have to decide the type of parent function. Is it x squared or is it absolute value of x? Because it's a U shape, it's going to be at x squared. So we need to know what the original looks like so we can compare. So in our calculator, we're going to put in just x squared. Go into the table and grab it. So as we said before, we're looking for where y values repeat. Look for the middle. Plot that point, and then keep going. Negative 1, 1, 1, 1, negative 2, 4, 2, 4. This one doesn't go to 9, but I'll draw it anyway. Negative 3, 9, and 3, 9. Then we are comparing. The one we just drew is the original. The one that's drawn, we are looking to see what changed, what happened. See the vertex move left and up. So move left 1 and up 8. So that happened. Anyone else see anything else that happened? Possible. Not compressed, but stretched. So it vertically stretched. And if we look at that distance, it's no longer 1, it's now 2. It did one other thing. Vertically. It's reflection. I'm just shortening things. So now that we know all the things that happened, it moved to the left, it moved up, it vertically stretched, it vertically flipped, then we can put all that together. So y equals the v vertically stretched by 2 would be our a. The vertical flip is also going to go on the outside. It's going to go on the outside in front of a. The up 8 is going to go on the outside, but that's going to be k. And the left 1 is going to go on the inside, that's going to be h, but it's going to be opposite. So putting all that together, things on the outside, we need a first, so I didn't put that up here, the equation again, but it's the same one from the last page. The vertical flip first, the negative. The a value, the 2. This is the x squared, so we need parentheses. You have an h, it moved left 1, but it's opposite, so it's really going to be plus. Square on the outside of that, and then it went up 8 plus. Questions on that before we do this last one? decide on which type it is. It's the absolute value because it looks like a B. So to draw in the original, we're going to go to our calculator. Type in alpha window. And it's the first one. And X. And then go into the table. And do the same thing. Find the point in the middle. Graph that point. And then go out from there. Negative 1, 1, 1, 1. Negative 2, 2, 2, 2. And really it just keeps doing that. So then if we're looking at the vertex that was drawn, we can see it move down to the right 3. Then I can also see that this looks wider than this one.